So we have discussed the thermohaline circulation, the great conveyor belt, and we have seen how this the cold water formation takes place at several places. What we call North Atlantic bottom water, then this Antarctic bottom water, and other cold waters. But now I will be discussing how this formation of water takes place, how the the formation of this cold water takes place. And before that, as I have already discussed, the evaporation plays the role. The latent heat of evaporation actually decreases the temperature of the ocean water, which results into the increase in the salinity. And another process like formation of formation of sea ice. This formation of sea ice also results into the increase in the salinity, and finally we result into the formation of dense high density water which goes and sinks down. So let us see what is the relation of temperature, salinity, density. For that I will draw a diagram. So I will be taking temperature on this side, and I will take salinity on this side. So this is the 0 degree temperature, this is the +1, +2, +3, +4 or +5. This is the 5, 4, 3, 2, 1 and 0. Then -1, -2, -3 and -4. And I will take salinity on x-axis, which is like 5, 10, 15, 20, 25, 30, 35 and like 40. So we know that the freezing temperature of fresh water is 0 degree. But the density of this fresh water is not maximum at 0 degree. So if this is the freezing point, this is the freezing temperature of fresh water when the salinity is 0. When salinity is 0, this fresh water will freeze here. And when salinity increases, the freezing temperature gets lowered. So it is marine water, the sea water, the saline water does not freeze at 0 degree. So graph goes something like this. This is the freezing curve. This is the freezing curve. This is the freezing curve of water. So fresh water freezes at 0 degree, and the marine water, which has the salinity of 30 or 35 or something like that, freezes actually at -1.8 degrees Celsius. So here this is the freezing curve. But what happens to the density curve? If we see the fresh water where the salinity is 0, the maximum density is at 4 degree. The maximum density is at 4 degree. When salinity is 5, 10, 15, the maximum density curve also decreases. But what is the difference of freezing curve and density curve? The slope of this density curve is steep. This density curve will come something like this. So there will be a point, this is the density curve, density maximum curve, or I can call it maximum density curve. So we have a maximum density curve and we have a freezing curve. They actually meet at this point where the salinity is something around 30 ppm. So at this salinity, we have the freezing temperature and the temperature required for maximum density is actually same, is coincident. So the coincidence of this maximum density and freezing is one of the important factor how how the formation of this dense water takes place. So at this temperature we actually start getting the very cold water, which is actually denser also, and then it sinks. So there is actually the brutal cooling at this at the southern ocean. There is a brutal cooling at the southern ocean. This water will then sink down and will move towards the east and northern direction, as we have discussed in the earlier lecture. So the forces behind are actually the evaporation that results into increase in the salinity, which results into increase in the density, and similarly the ice formation, which results into the increase in the salinity and finally density. So this is the way how we get North Atlantic bottom water over here, then we get Antarctic bottom water over here, and then we have again what we call intermediate water, Atlantic intermediate water. So what does this Atlantic intermediate water mean? This water is somewhat different. This water mass is somewhat different than North Atlantic deep water and Antarctic deep water. This intermediate water, Atlantic intermediate water, is somewhat different from these two water bodies. How it is different? The density is not that high in comparison to these two water masses. The salinity is not that high, and yes, cooling plays the role, but the cooling is not exactly because of the same processes that took place in other two or other three water masses. In this case, it is the Ekman transport. It is the Ekman transport and mixing of different waters, which results into relatively increase in the salinity, but not as that much that as in the previous two or three water bodies. So we have Atlantic intermediate water body also, water mass also, which is relatively less denser, less cooler or less saline as compared to other bodies, and this also sinks. This sinking takes place around 50 or 60 degree southern latitude. So now let us see the impact of this on the global climate, the impact of these bodies on the global climate. Obviously it will be having impact on the global climate. As we have seen, this is the cyclic phenomenon which almost goes to each and every ocean. So any change in this meridional circulation will have a drastic impact on the global climate. So first impact is that when the upwelling takes place, that is taking place in the southern Indian Ocean, that is taking place in the Pacific Ocean also, and some other places. This water brings the nutrients to the surface. When this water brings nutrients to the surface, it blooms the fishing industry in that area, and it and other like algae and all those, they depend on the nutrients which come along with upwelling of water. So if any change is there, any climatic change that disturbs the normal movement, normal circulation of this thermohaline circulation, it will definitely affect the fishing industry and other industries. Then another impact that we can see is that the recent research is saying that the Gulf Stream, that is actually the one of the surface component of thermohaline circulation, which flows in this eastern coast of North America, there has been 30% decrease in this Gulf Stream. What does that mean? This Gulf Stream is actually responsible in taking the warm water towards the polar regions. That is why the temperature of the Europe is comparatively warmer than temperature of this area. Although this comes in the low latitude, we should get maximum temperature here as compared to this, but which is not true. So this Gulf Stream, which is taking warmer water to the polar sides, if there is any decrease in the amount of water taken, it will definitely bring cooling in this area. So the temperature variation will take place in this area. Now if the warm water, if this Gulf Stream, this is the another effect, if this Gulf Stream does not go to the northern region, or if there is any decrease in the Gulf Stream, amount of water or heat taken from equator towards the polar regions, one another effect will be that there will be a rise in the ice caps. So there will be more ice caps. The melting of ice caps will not take place in this area. When there is a rise in the sea ice, it will actually increase the albedo of the earth. When the albedo of earth increases, albedo means how much radiations are reflected back. If there is more albedo, that is also having a significant impact on the climate or temperature of the area. So then another effect is that the thing is that when this cold water comes to the surface, the cold water has a tendency to absorb more and more carbon dioxide. So this cold water becomes the carbon dioxide sink also. It takes the carbon dioxide from the atmosphere, and this carbon dioxide then goes into the ocean, because cold water has more tendency to hold the carbon dioxide. So it has a direct impact on the amount of carbon dioxide in the atmosphere. So if I try to conclude the things, that is, we have what we call the formation of cold water here, the formation of cold water here, the intermediate water here, then we have upwelling in the Pacific, we have upwelling in the Indian Ocean, and then this is how the thermohaline circulation goes. And then we have seen how the freezing takes place, what is the relation between the salinity, temperature, freezing curve and maximum density curve, and we have seen the impacts of impact of this ocean, this thermohaline circulation on the global climate. Thank you very much.